Welcome to a fascinating journey into Einstein's spacetime, where time and space aren't just separate entities, but interwoven dimensions that shape the very fabric of our reality. We'll explore why time can slow down or speed up depending on who's observing it and who's traveling. We'll unravel how gravity itself can alter the flow of time. Then, we'll dive into something even more mind-bending, the idea that the arrow of time, the forward flow we all take for granted, might not be as fixed as it seems. And if we dare imagine a future where entropy, often considered the driver of time's irreversibility, can be reversed, how would that transform our society? To understand Einstein's revolutionary idea, let's start with a simple notion. Before Einstein, we mostly thought of space and time as separate. Space was where events took place, and time was a universal clock ticking the same way for everyone. Einstein's theory of relativity changed all that. He showed that space and time are part of the same fabric, spacetime. If you imagine spacetime as a giant stretchable sheet, mass and energy warp it. A star, a planet, even you and I have mass, and that mass bends the sheet of spacetime around us. This bending, or curvature, is what we feel and describe as gravity. Here's where things get really interesting: time isn't separate from this curvature. When spacetime bends, time bends too. Near a massive object, like Earth or, more dramatically, a black hole, time actually runs more slowly compared to a region of weaker gravity. If you had two perfectly synchronized clocks and placed one near a black hole and left the other far away, the one near the black hole would tick more slowly. Bring those clocks back together and you'd see a real difference. What's happening? You can think of time as a kind of marker. Everything that exists, every atom, every photon, every person, is being marked by time. Time is like a pen that's continually writing our story. But when gravity is strong, that pen's writing slows down. It's like pressing the pen into a thick, gooey substance. You can still write, but it takes more effort and moves more slowly. The stronger the gravitational field, the more sluggish the marking becomes, and the slower time flows for that observer relative to someone in a weaker gravitational field. Now consider an observer versus a traveler moving at high speed. According to special relativity, if you zip around near the speed of light, time slows down for you relative to someone who's standing still. From your perspective, your clock ticks normally. But you'd see the other person's time moving differently. From their perspective, it's you who's slowed down. It's symmetrical in a strange way, until someone changes direction or returns home. Then you see who has really aged less. This is the famous twin paradox scenario: one twin travels near the speed of light, returns, and is younger than the twin who stayed on Earth. The key takeaway is that your movement through spacetime defines how you experience time. Gravity and velocity both shape the trajectory of the time marker. You never feel your own time slow down, you always feel time passing at a steady clip. But when compared to another observer, these differences emerge. So far, we've discussed why time can slow down. But what about the direction of time? The arrow of time that seems to always point forward? Under Einstein's equations, there's nothing preventing time from going backward as far as the raw math is concerned. Yet, we never see a teacup leap back up from the floor onto the table and reassemble itself. Why? This is where entropy enters the picture. Entropy is a measure of disorder, or how many ways a system's components can be arranged. Low entropy means everything is orderly, high entropy means it's more chaotic. The second law of thermodynamics tells us that in an isolated system, entropy tends to increase. That's why eggs break easily but never spontaneously unbreak. It's why cream mixes into coffee but never separates back out on its own. Entropy increasing gives us a natural arrow of time. It's the reason we remember the past and not the future, and why we feel time moving forward. But imagine for a moment that entropy isn't just a classical concept. Some theories suggest entropy is rooted in the quantum realm, where information and order can be incredibly subtle. If quantum-level technology allowed us to stir entropy, to shuffle it around or even reduce it, we might be able to influence the arrow of time itself. If entropy's increase defines the forward direction of time, then manipulating entropy might let us push that arrow backward, or at least neutralize it in some region. Suppose a scientist, by sheer accident, discovers a process that locally reverses entropy. They might see a system spontaneously move from chaos to order. It would be as if broken pieces of a vase decided to reassemble themselves without external guidance. That would be a hint that, in that localized region, the arrow of time had been flipped. If we managed not just to observe but also to control this process, imagine the societal implications. We've always been passengers on the river of time, carried inexorably forward. But if we gain the power to reverse entropy, we might become navigators instead of passengers. We could, in theory, rewind certain events, restore states of being, or maintain perpetual youthfulness by reducing entropy in biological systems. Factories could restore worn-out materials to a pristine state, eliminating waste. We could correct mistakes in experiments by literally rolling back time to before the error occurred. This would raise profound questions. Who controls this ability? Would it create time inequalities, some people resetting their lives while others can't afford it? What would it mean for our memories, our concept of progress, and our understanding of cause and effect? The ethics and governance of such technology would be as challenging as the physics behind it. We started with Einstein's spacetime, an intertwined stage where time and space flex and bend. We learned how gravity and motion affect the flow of time, and why time's arrow seems to point forward because of entropy's relentless increase. But we also opened the door to a speculative realm. If entropy is truly a quantum-level phenomenon, and if we could learn to manipulate it, time might no longer be a one-way journey. Such a discovery would be monumental. It could redefine life, society, and our place in the universe. Instead of time controlling us, we could begin to control time, though whether that's desirable, manageable, or safe remains an open question. Thank you for joining me on this deep dive into spacetime, time dilation, and the tantalizing possibility of entropy reversal. As always, these ideas remind us that what we take for granted, like the flow of time, may not be as immutable as we believe. Stay curious, keep questioning, and until next time, this is Amy, signing off.